Hey, welcome back to Algebra 2. Today's lesson is 8.1, Introduction to Rational Functions. So, basically, in rational functions, all we're talking about, and it says rational functions, it really should say rational expressions. We're going to be talking about rational functions and rational expressions and simplifying them. All right, so today when we talk about rational functions, we'll be talking about whether or not a function is defined at every point. And in this case, in exercise 1, you will see that consider the rational function f of x. For what value of x is this function undefined? Now, we can always go to our calculator, but unfortunately, the calculator is only going to give us those numbers that are integers. Unless we change the table set, and we can do that, and I can show you how to do that, but it still will not, there's no way that you can do every single number. It's not going to, a table is not going to give you irrational numbers or anything like that. So you have to be able to do this algebraically. And when we're looking for an undefined, we don't care about what's going on in the numerator. We're very concerned about what's happening in our denominator. So we know that x minus 3 cannot equal 0 when we talk about a fraction. So in this case, we add 3 to both sides, and x is equal to positive 3. So it says, for what value of x is this function undefined? It's x equals 3. And why is it undefined at this value? So f of x is undefined at x equals 3 because don't like using it. Remember I told you we shouldn't be using pronouns, because 3 is where the denominator of f of x is 0. Now, that's the reason we call it a rational function. Whenever we see rational, we're assuming fractional, because the definition of a rational number is any number that can be represented as a fraction. So a rational function is generally a function that is represented as a fraction. Okay, so exercise 2. Finds all the values of x for which the rational function h of x equals x plus 5 over all of that is undefined. So, and it says verify using your calculator, and you can do that in this case because our numbers are going to turn out to be friendly, at least a little bit. So again, not interested in that x plus 5. We very much are interested in this 2x squared plus 11x minus 6, and we want to know where it's equal to 0 because that's where it's undefined. So in this case, we're simply going to factor this. Now, could you use your calculator and then work your way up? Absolutely. So we're talking about 6 and 1. So 6 and 1 go this way. I know it's a positive 11. So this has to be plus. This has to be minus. Just giving it a quick check, I know that we have negative 1x and we have a positive 12x. And when I add them together, I get a positive 11x, which is what I need right here. So I have 2x minus 1 is equal to 0. I have x plus 6 is equal to 0. Add 1 to both sides. 2x is equal to 1, and x is equal to 1/2 when you divide both sides by 2. And minus 6 and minus 6, and x is equal to negative 6. So on the table, if you had put this in your calculator, it's not going to give you 1/2. Remember, your table basically will do 0, 1, 2, 3, 4. You're going to have to change your table set in order to get that 1/2 to be in here. And sometimes we're just not realizing that to do that. Another way you can do it is look at your calculator, and very easily you would see that negative 6 would be 1, 0. And you could pretty much guesstimate that the other one would be 1/2, because when you put in your calculator, it would look something like this: 1, 2, 3, 4, 5, 6. So negative 6 would be here. And if this is 1, the other one would fall right there between the two, and your parabola would look something like this. right, verify for calculators. So what values? So basically, make sure I always make sure that I put boxes around my actual answers. All right, because there's a lot of work going on here. Make it easy for somebody to find the answer. All right, moving on to number 3, exercise 3. Which of the following represents the domain of the function f of x? So this one's saying which represents the function. If you take a look at your answer choices, how this is written is x such that x does not equal positive and negative 4 or 3 or negative 2 and 8 or negative 6 and 3. So again, we're not interested in this. We're just interested in this denominator. This one is pretty easy to factor. Again, if factoring is not your thing, you could put into your calculator, find your zeros, and because this is multiple choice, you don't even have to show the rest of the work. So 16 would be minus 8 and plus 2, because we have a negative 8, then we have positive 2, which is a negative 6. So x minus 8 equals 0. So x equals positive 8, and x plus 2 is equal to 0. So x is equal to negative 2. So remember, this is where it is undefined. So it's defined everywhere else except for these 2 points. So that's why this is my answer. X, all of x, meaning all real numbers x, except for x is not equal to negative 2 and 8. Okay? So when you're ready, meet me at exercise 4. So g of x and f of x. So just a quick review on how to deal with composition of functions. So here's my g of x, here's my f of x. So what I'm going to do is I'm going to start with g of x. So g of negative 2. So I'm going to use g of negative 2. So 3 times negative 2 minus 2. So this is equal to negative 6 minus 2, which is negative 8. So now I'm going to take that negative 8 and I'm going to put it into my f of x. So now I'm going to do f of negative 8 is equal to 2 times negative 8 plus 1 over negative 8 plus 5, which is equal to negative 16 plus 1, which is negative 15, and negative 8 plus 5, which is negative 3. So my answer is positive 5. Same situation with b. I'm going to do g of 2 first. So I'm going to do 3 times 2 minus 2. So you get 6 minus 2, which is 4. So now what I'm going to do is f of 4 is equal to 2 times 4 plus 1 over 4 plus 5. And this gives me 9 over 9, which is equal to 1. All right, the last one. Now this is in terms of x, so not horrible. I don't necessarily have to do anything to my g of x. My g of x is simply going to be 3x minus 2. And wherever I have that 3x minus 2, I'm going to take my f of x, which is 2 times x plus 1 over x plus 5. And wherever there's an x, I'm going to put my g of x, which is 3x minus 2. Now we can drop the parentheses in the denominator and distribute the numerator. So this becomes 6x minus 4 plus 1 all over 3x minus 2 plus 5. Just drop the parentheses because there's nothing in front of them. Let's combine like terms. So 6x minus 4 plus 1 is 6x minus 3 over 3x minus 2 plus 5 is 3x plus 3. And you have to make sure that everything is in simplest form. So we're going to say we're going to factor out a 3, and you get 2x minus 1. Then we factor out a 3, and we get x plus 1. And then we simply just cancel out my 3's. So my answer is going to be 2x minus 1 over x plus 1. Now you can leave the parentheses around it. In other words, these here, you can leave these parentheses around it because what that does is kind of protects it. So you can't, because what some people want to do, which makes me absolutely crazy, but I understand why they want to do it. They want to do this. They want to cross out the x's, cross out the 1's, and come up with an answer. But even the smartboard knows that that's not right. So my final answer is going to be that 2x minus 1 over x plus 1. Exercise 5. Find the formulas for the inverse of each of the following simple rational functions below. Recall the first step, switch the roles of x and y. So in this case, we're going to have x equals y over y minus 2. Now we have to solve this for y. When you have y's in a couple of different places, I think the easiest way to do this is to cross multiply. So I put this over 1, I do this times this, equals this times this, and I get y equals x times y minus 2. Remember, you can protect any type of an expression that has more than one term in it, then you can protect it. So this becomes y equals xy minus 2x. The next step is to isolate the y's. So let's bring the y's over. So minus xy, and I get y minus xy is equal to negative 2x. Factor out the y, and then divide by what's with it. These cancel. So my final answer is 2x over 1 minus x. Aren't these fun? These are great. Love these. So inverse, one more time. We're going to switch the x and the y's. If it's okay, I'm going to write x over 1 equals y plus 3 over 2y. And then we're going to cross multiply. Whoops. Sorry about that. I have to find it. There it is. So I have y plus 3. Doesn't matter which one you start with. Y plus 3 equals 2xy. So I guess we should bring this over to this side. So I get 3 equals 2xy minus y. Factor out the y. And divide by what's left. These cancel. So you get y is equal to, I'm sorry, I should have written this way. Y is equal to 3 over 2x minus 1, which is the definition of my inverse. Here I should have said this is equal to y. Technically it's y inverse, but anyway, we'll leave it as just y. This is the inverse, as is this. So this is just diving a little deeper into manipulations of algebraic expressions. So they can be fun. Don't think of them as being tedious. They can be a lot of fun. So if you've been instructed to do the independent practice, make sure you get that done. If not, do it in class the next time. All right? So as always, make good choices, and we'll see you next time.